Okay, part two. So yeah, my mic was working. Anyway, let's carry on. So yeah, you got your gear working. Great, good for you. We're going to do a slightly easy one again now. We're going to put this red guy, or this red, what would be a connecting rod or a linkage, onto this little nubbin here. So make sure it's free. It is. Good idea, by the way, when you choose Mates to click anywhere in blank space so you don't have anything selected. Reason for that is, look, if you have something selected and go to Mate, can you see it automatically puts that face in there? This is the cause of a lot of kids getting it wrong because they don't realize they accidentally clicked something before selecting it. Anyway, so I'm just going to go in there and delete the selection. Right, I want you to start by attaching this cylinder to that cylinder. So I'm going to zoom in. Remember, it's always the inside of the cylinder you pick, the face of it. I'm going to pick the face of the outside of here. Okay, now that should bring it over. It's lined up, it's in the background, doesn't matter, but I'm going to click the tick. Now what I've got to do, in my case, I've got to adjust my view and grab this and bring it out here a little bit so I can get to it, okay? Hopefully it's not embedded totally in it, but drag it out. And now I know that that bit there would attach to the back of this. So those are the bits I'm going to pick. That face, rotate my view slightly, and this face. There we go. Click the tick. Fine. Now, we don't need to do anything more than that because this is designed to sort of pivot around it, kind of like it's doing there at the moment. So we can leave that one alone. What should we do next? Let's put this, I think they call this a gudgeon pin. We're going to put our gudgeon pin into our cylinder. So I'm going to do into our piston. So I'm going to pick the outside cylinder of my gudgeon pin and zoom in and pick the cylinder on inside the piston and click the tick. Now, obviously, this is free to slide left and right still. We've got to somehow fix it to the outside. Now, this is a little bit more advanced. We've got a flat surface and a curved surface. Now, usually, it will get it right. If you pick the flat and you pick the curve, if I just manipulate my view, that has actually done it correctly, okay? It's put it, can you see it's chosen a tangent constraint? Look at the symbol, circle against a flat edge. That's what we've got going on here. Sometimes when you do it, it will get it wrong and it will look like the alternative arrangement, which if I click here, you'll see it puts it tangent to the outside. So if yours did that, come over here and flick this. If it looks like that, great, hit the tick and lock it in. Okay, perfect. Right, another mate we're going to do now. We're going to put this cylinder onto here. Okay, so go and choose that cylinder and go and choose the inside cylinder of here. Okay, don't worry if it looks weird, click the tick, just confirm that it's on the same axis. Okay, don't worry if it interlocks or overlaps or anything like that because we're gonna sort this out in a minute when we put this guy on. Okay, right, so that bit's sort of there. We're now going to mate this kind of piston holder. This would be, for those of you into car engines, this would be the cylinder block. So I'm going to take this big fat face on the back and mate it to the front face of this. Click the tick. Now that's 1 degree of locked. It's fixed to the face, but it can still slide left and right, up and down. We're going to have to do what's called an offset mate now, and I'm deliberately going to do them with the wrong offset and then ask you through trial and error to work out the correct offset. That's what these magic numbers X and Y are, okay? I've written on your worksheet, what are the magic numbers X and Y? I'm not going to tell you because I'm going to hide it in the video. You're going to have to experiment and find out the optimum position left to right for this block. Now, how do you do an offset mate? Well, let me show you. Normally, if I was going to say click that face and this face, you see what it's done? It's brought them in line with each other. Normally it just assumes you want them to line up. If, however, you click this little arrow box here, you'll see you can type in a number. So for my first go, I'm going to type something I know is deliberately wrong, 15. In fact, no, I'm going to go 10. Okay, good. Happy with that, so click the tick. Can you see what that's done? It's now locked to the board, left to right, but not up and down. It's been locked 10 millimeters away from the edge. That is an important thing. If I was going to build this in real life, I wouldn't faff around screwing it on. This is plastic to plastic, so I would just super glue this into the right position. But the point is, I need to know where that position is, so I might need to change it. You should know how to alter these. How do we do it? Who can remember? Nobody. Well, go back through your list of recent mates. There you go, look, distance 1. If you weren't happy with the 10, you could come back and change it here. So if I wanted to make it 12, for instance, it's just shoved it another 2 mil, click the tick. Right, you're going to do another offset, mate. So this, by the way, would be your magic X number when you find it. 12 and 15 are not the right answer. I'm now going to click the top of this and the top surface of the back rectangle. As you can see, by default, it wants to make them flush. I know I'm going to want some kind of offset. I'm going to just try 50 for now. That's not the right answer, but I'm just going to do it to lock it in. Press the tick. Now, because I have done left to right, up and down, and back and forth, this is completely fixed now. I can't drag it or move it. I have fixed 3 dimensions. This is what I was talking about earlier. 3 degrees, X, Y, and Z. Okay, there's only one thing left to do now, really, and it's put that piston inside that ball, and then figure out what your magic X and Y numbers are, and I'll show you why you need to experiment. I've deliberately designed it this way. Right, to put that in there is easy. We get the Mates tool, we pick the outside cylinder of that, and we pick the inside cylinder of this. Okay, now in my model, this all snaps together nicely because I made sure that the center of this hole from the edge of here was the same as the height of this thing as well, so it all lines up. Okay, and you'll notice my red piston sits exactly in the middle. Right, that piston used to slide up and down, left to right on this, remember? But now I've locked it left to right, it doesn't. Now, the reason you're going to have to mess with magic numbers for this block is as follows. Who can spot the issue? Let's have a look. Let's animate it. Okay, so fine. Error, okay? If this was real life, you can see that red block is passing through my grey block. That can't happen, right? So something needs to happen. We need to, and you need to, change the position of this guy, both left to right and up and down. Up and down will be when this red block doesn't collide with either the top, which is fine at the moment, or the bottom. So the more astute amongst you will realize it needs to come further down, but how much is the key. Too far and it will go, the problem will happen the other way. The other thing I want you to do is left to right. So at the moment, my piston, if it's fully extended, when it's at full stroke, which is there, or thereabouts, I want that surface to be at the same height as this. And when it's at lowest stroke, which is like there somewhere, that should be over here. So basically, it's got to come left a certain amount and down a certain amount. That's all you've got to figure out. How do you change it? Well, remember your training. Which is the thing we've got a problem with? It's that guy. So click on it. That shows you it over here. Click the arrow. Click the folder with mates. These are all the mates that belong to it. Which mates do you think it is? Is it the round one? No. Could it be the 2 that have distance on them? Yes, it is. So I'm now going to pause the video and rectify this, and I'm not going to tell you the magic numbers, but I'm then going to come back and show you it correct. Okay, now I've done it. However, the more observant among you will notice another problem. What you have set as Mr. Winter is more or less impossible. Well, it is, because I want you to add I want you to make a modification, because this is something we have to do in design engineering. We build stuff, we test it, sometimes virtually, and realize that things aren't going to fit or they're going to collide. So I have set this up left to right perfectly. Can you see it full extent? So the piston comes right smooth with the edge, look, doesn't go any further, and all the way back, look, just kisses the edge. So left to right, I've got perfect. Good luck finding out the magic number. However, up and down, even though it's balanced, you'll notice it just kisses the edge there. Can you see there's an ever so slight collision? And it just kisses the edge there, ever so slight collision, okay? Now, we could spend ages faffing around making this shorter, or we could just make a simple modification. What if we put a chamfer on this edge to make some clearance? That's what an engineer would do. So I want to edit this part. This is going back to the previous video before this one. Let's work on this part. So right click on it and click Edit Part. Now, on your screen, I don't know why my computer doesn't do it anymore. Everything else should go transparent and this should remain colored. At the very least, if yours looks like mine, make sure that guide block has gone blue over here. That means you are working on this part. It's very important you do that. So that was right click, edit part. I'll just do that again so you know, sorry. Right click on the part, edit part, this little pencil and a block. Anyway, now go and choose a chamfer. So you get that from the fillet menu, drop down and click this edge here. Now, if it doesn't show anything, tick full preview, and the chamfer I think works. I would set it to something like 80 degrees because we want quite a raked angle. We don't want it going that far. It only actually needs to go 2, I think, from memory. That should give us plenty of clearance. So 2 millimeters and 80 degrees, click the tick. Okay, we're done working on this part, so we can click this little icon up here, return to assembly. And now let's check it out. There we go. Just misses, just misses. Okay. Right. Just to wrap it up, I would like you to go and modify this inside edge of this and put a chamfer on it. I'm going to pause the video and do it in secrecy. Remember, edit the part first. Okay, so it should now look something like this. Now I did, for those of you who want to know the numbers, I did 45 degrees and 2 millimeters. So again, that would give us even less chance of catastrophic crashing together. Now, this is where SolidWorks is incredible. I can be reasonably confident that this is going to work, right? I know it's going to do its job because I've tested it. I can see it all moving. I can see it functioning. I can see where the bits collide. I won't bore you with it on this video, but there are even ways of it detecting object collision. Right? It will tell you if that red thing hits another thing because it will stop. Right, the final finishing touch for you to do, and you're going to figure this out all on your own. I want you, as per my example here, not that one, the other one. Let's open it. Be under recent, sorry. I want you to, what's going on in there? Okay, I want you to rebuild, sorry, not rebuild, edit this backboard and put a fillet on each corner. I want you to edit the backboard, do a sketch and write some text and then make it cut into your work with your name on it. I've done Mr. Winter was here. That's the proof that you did it yourself and you didn't just get your mate to share the file with you, or at the very least you copied the very last stage. And I'd also like to change the color of all the parts to make them stand out. So the way you change the color, I'll just minimize this one. It's very simple. Let's show the open one. For some reason, some of them are colored on mine, but all you do to change the color of a part is right click on it, go up to this one that says appearances, click the arrow and choose this one. So you don't want to change the face, the boss, you want to change the color of the whole part. And from then on, give it a second to load. You can either go and choose an appearance, like a texture. So these are all the textures, or you can just go and pick up plain color. I don't want that, so I just want color, plastic, and then choose red. I don't know why it's got a texture on it, okay. But you get the idea, you can mess around. Now, if you're not happy with that color, just click X, or you can also, if you don't like the color on something, so say this red thing here, you can right click it, click here and choose remove all part appearances. There we go, and that's taking it back to boring standard gray. So basically, to finish up, color everything a different color, you choose, put your name and the fillets on it, make sure you've added those fillets in, and shout, yo sir, I've done it, come check it out and revel in your glory. And I hope you've learned something from that process. Well done if you have. Take a screenshot, obviously, and then put it on your OneNote to prove it. First person, by the way, to tell me the magic numbers, both of them correct, I'll give college rec to.